In this video, we are going to work with another type of monitor point called MONPNT2. So this entry lets you track specific quantities from element responses like element forces or stress values. So here's a quick agenda of what we're going to cover. I'm going to create one or two monitor points. I'm going to interpret the data, and then I'm going to output the results to a CSV file. And then this won't be covered in this exercise. This is the agenda from a different video, so that's why it's kind of out of sync here. So again, I'll walk you through how to create one or two monitor points. I'll talk about interpreting the results. We'll go ahead and output the results to a CSV file. And then we'll go ahead and create monitor points for dozens or hundreds of elements, if you will. So we're effectively creating hundreds or thousands of monitor points. And then towards the end, I'll go over an easier alternative method. So I was going through this exercise and I realized maybe there's another way of doing this. So I'll show you another way. References. So a lot of this is coming from, or a lot of the information you see in this video is coming from the quick reference guide, the linear static analysis user's guide. Another document that's very important here is the DMAP programmer's guide. So I'll explain why this guide is important later on in this video. Now, everything we're going to show today is going to be done in a web browser. So we're going to actually use Natsran in a web browser. We're going to create the monitor points in the web browser. So here are the beams we're working with today. If you want to follow along with today's exercise, you can visit theengineeringlab.com, click on free trial, fill out the form, submit the form, and we'll go ahead and give you access to today's web app so you can go ahead and practice what you see today. Now, let me go ahead and see. Let me delete these old monitor points. Let's go ahead and start from scratch, essentially. So what a monitor point 2 does, let me go ahead and do this. Let me open the quick reference guide. Let me show you a C quad 4 entry. So a C quad 4 entry, it's going to output a lot of values for you. It's going to output forces in the element coordinate systems. So let me see if I can find, I guess we don't have that. It's going to output forces in the element coordinate system, and it's going to output stresses at the top and bottom fibers of the thickness of that shell element, if you will. Here in this little window are some output available in the F06 file. So here we have the forces in the C quad 4 element. We have stresses in the C quad 4 element. If you have a need to track specific values, for example, you want to track the force along the x-axis of the element coordinate system. If you have a need to track the stress along the x-axis of the element coordinate system, the monitor point 2 entry lets you do that. So now this is the goal. We want to monitor the output, the force along the x-axis, the stress along the x-axis for the bottom fiber at a thickness of -5 times 10 to the -3 for this element 1341. So how do we do that? Let's go ahead and create two monitor points. We'll call this P901 and P902. So with these names, you want to make sure they don't conflict with the other names of other monitor points like MON DSP1, MONPNT1, MONPNT3. So make sure these names are unique. So we'll call this the force X in ECS of element 1341, I believe it was. And then we'll say this is stress X in ECS of element 1341, bottom fiber. So here we've supplied our labels, and now we'll update the table field. We'll say, okay, one is a force, the other one's a stress. We'll go ahead and close some of these old windows here. For the type, this is all going to come from C quad 4. So here, one trick, just in case you're not aware of it, when you select the menu the pull down menu, you can type in C, then Q. Let me show you, C, then Q. And this will jump to the option C, Q. And the first option is C quad 4. So again, type in, or click on the menu, type in C, Q. It takes you to that value, C, Q. Select the value. So it's just a shortcut just in case there's a long. So here, let me show you that again for maybe C tria, C tetra in this case. So C quad, it takes you here. Okay, now for the element ID, we'll go ahead and screen pick. I actually don't know where element ID 1341 is. So let's do this. 1341. Let's go ahead and look at. So, oh, right. So it's this element. Okay. So let's go ahead and screen pick element 1341. So let's go ahead and pick this element here. Let's go ahead and reduce the picking sphere. So one nice thing about this picking sphere, it feels a lot like you're picking on the screen. Like you're dragging your finger and you're picking an element. That's one thing I like about the picking sphere. Let's go ahead and do this for both monitor points. Okay, so here we're tracking data for the force and the stress in element 1341. This is where it gets a little complicated. So if we click on description, or if we click on display description, we get information about this column, NDDL item. So now you need to know the actual name, the actual abbreviation used for these columns internally in Natsran. So I wish it was FX. We can just type in FX here and it would work, but unfortunately it will not work for the force. For the stress, I wish we could just type in normal X and it would work and it would get us a stress value, but unfortunately that's not how it's going to work. So let's go ahead and open the DMAP Programmers Users Guide. So that would be this document here, DMAP Programmers Guide. Now let me look at my notes because I actually have a page where this information is located. So we'll go ahead and type in 987 here. And nope, this is not the correct page. So here I'm looking for page 987 in the PDF. Now I'm using Natsran 2025.1. So if you're using a different version of Natsran, the page number will be a little different. But here, let me show you what I'm doing. I'm going to this section here, OEF, Table of Element Forces, and I'm looking for C quad 4, which brings me here. Let's go ahead and make sure. Right, so these are the abbreviations here in this column, MXR, MYR, and so on and so on. Those are the abbreviations or the names for the forces on the X and the Y axes, but these are the values for if you're performing a dynamic analysis. What we want are the ones, and here, I don't even know if I'll be able to find it. Was that really for C quad 4? Right, okay, what I want is this other set of rows. So I'm going to 9-8. I'm just basing this off of my notes again. 987. So let's look here. So that would be this page. Okay, so I confused myself a little. So scroll down to page 9 and 7, which would be this page here. So in the top right hand corner, you see it says page 987. Look for this row, real or random response. This has the abbreviations that you want to use. So let me go here and do this. So here we have abbreviations that the F06 file has. And in parentheses, I'm going to type in the abbreviations that are used internally in Natsran. So you use MY and MXY. So I think you get the idea of what the corresponding value or abbreviations are. So it's these names that you have to use. So we'll go ahead and type in MX in the web app. And let's try and run this. Here, this abbreviation here for the second line, that's not correct. And I expect Natsran to give me a warning. One other thing, a lot of the time, if you make a mistake in supplying the data, you do not get a warning, or you do not get an error. Natsran will continue the analysis even if there was a mistake in the input data. Here what you get is a warning message. Let me go ahead and show you what this warning message looks like. I believe it was this one. So this is the warning message you get. Again, you do not get errors if there was a mistake in the data. You get warnings. Here you get told that monitor point P902, normal X, which was the name we provided, so normal X in this column, NDDL item, Natsran doesn't know what that name is. So it's very important that you use the correct name from this document. Towards the end of this video, I will show you possibly an easier way to get this data. Let's go ahead and now look in the user's guide for the stress name. So let me read my notes here. So for this, we're going to look in page 1103. 1103, so we have to scroll down a little. 1103. And then when you look at this data, you get the same abbreviations almost repeated. I'll explain why in a moment. So here, these are the abbreviations for strain. If you're performing a statics analysis, notice that in this row it says real. In this next section of rows, it says real imaginary. These are the strain abbreviations if you're performing a dynamics analysis. Here are the abbreviations if you're performing a random response analysis. Here, this row says stress. So now these are the abbreviations for stress. Here it says real, so these are if you're performing a statics analysis. Real imaginary if you're performing a vibration and dynamics analysis rather. Okay, so here we see this is, if we want the stress at the bottom fiber, so here Z1 would be the bottom fiber, Z2 would be the top fiber. The stress along the x-axis would be abbreviation SX1. So if I look back here, let's go ahead and type in the abbreviations here just so you're aware of what they are. So for normal X, abbreviation is SX1. And then here SX2. And then I think you get the idea. So here we have to actually use SX1 here, SX1. Once you do that, now we can run this Natsran analysis and that warning message is no longer present. This warning message that was there before, it should not be there anymore. So now that we've successfully configured these monitor points, let's look at the output. So we'll go ahead and look at the F06 file. We get this section. So you could look at the data either in the web app or you could download the F06 file and then look at the data in the F06 file. So here I've downloaded the F06 file and now let's open it in my text editor. Let's go ahead and look for that monitor point. So I always forget what the name of the monitor point is. P901. So let's go ahead and look at that. So this is I'll open this file side by side. So further down in this file, I also outputted the force and the stress for element 1341. So recall that the goal here was to get the force along the x-axis, so that would be this value, and to get the stress indicated here. So that was the goal with these two monitor points. Let's confirm we do in fact get those values. So here is the output for those two monitor points that we created using the MONPNT2 entry. So monitor point P902 and P901. So this is kind of flipped. So this table, this row, this value column, this is going to contain the value of the force along the x-axis. So it's negative 2.36 times 10 to the 3. If we look at the force table, that's the same value we get. Now, what about the stress? We expect the stress value of negative 2.4 times 10 to the 5. If we look at this other table for monitor point P902, we get the same value, negative 2.4193. So we've successfully achieved our goal. We want to get the force and the stress along the x-axis. Okay, now I know many of you might be tempted to read this text file. I encourage all my developers to avoid reading the F06 file as much as possible. In my opinion, this data is not friendly for reading. There is an alternative way. And then I know some of you might be asking, well, just output this data to a punch file. That's not possible. You cannot output this data. As far as I know, you cannot punch this file to a punch file. There's an alternative. This same data is stored in the H5 file. So we'll go and click on run and then resolve files. Here we have the H5 file. You can open the H5 file in this other tool called the HDF5 Explorer. Here you can select the MONPNT2 dataset. So all the data from those monitor points we created is in this table now. You can now go ahead and click download CSV. And you have this new CSV file called acquired dataset. Let me go ahead and delete these old files. You can open the same data, the same table in Excel now. So here's the CSV file. Here are the same values. So the same force, the same stress values that we exported to that monitor point. So this force and this stress here. It's in the monitor points, and I've output the monitor point data to Excel. So now I can go ahead and hand this off and do some additional hand calculations if you wanted to. Now, later on in this video, I'm going to show you maybe a 5-second or 10-second approach. So in this other method, I'm going to avoid creating a monitor point altogether, and I'll show you an alternative way to do this. Okay, let's see here. What else should I do? Let me look at the agenda. So we created a monitor point, we interpreted the results, we output the results to a CSV file. Now you want to output the data, or you want to use the CSV file to create dozens or hundreds or thousands of monitor points. So let me do this. Let me make one modification here. Right now, I'm outputting data for just one element. I'm going to output data for all the elements. And then we'll turn on the plot option just so the F06 file is not 50 gigabytes big. Okay, let me do this. Let's now create additional monitor points. So suppose you want to do this. You want to get the force along the x-axis. Let me actually show you what the x-axis looks like. So the x-axis is going to be represented by the red axis. Suppose you want to get the x-axis, or the force along the x-axis for all of these elements on the top flange, if you will. Well, how do you get that? This is how you would do it. First, let me do this. Let me determine what the element IDs are here. So let's go ahead and select element IDs along the top flange. And now I'm going to store these element IDs. Let me save a CSV file of this actually. List of element IDs .csv. We want the file extension to be CSV in this case. I'll get back to these element IDs in a moment. So now let me do this. Let me delete the monitor point for the stress. And now let me export a CSV file of this table. So now I can open this CSV file. Here we have one monitor point defined. And let me open the list of CSV values for the element IDs. So remember, I created a CSV file of the element IDs. What I'm going to do here, I'm going to select that row and copy it. And then I'm going to paste it here. I'm going to use the transpose option. And now I can create, I'll leave that blank for now. I can use Excel to quickly define the configuration for all of these monitor points. So you can imagine if I had to create hundreds or thousands of these monitor points, I can use Excel to quickly do this. So let's go ahead and save this file. And then if we look at that updated CSV file in the text editor, this is what it looks like. Now what I can do, I can import the CSV file, table A, and now all the same data that I program in the Excel file, it's now in the web app itself. So you could do a few things here. If you want, you can just copy the entries on the right, and now you can move these entries to maybe Patran or MSC Apex or some other mesher or FEA tool for MSC Natsran. What I can do now, I can actually run Natsran. So let's run Natsran. And we'll do the same thing. We'll go ahead and look in the F06 file. And now the F06 file, it's going to have even more monitor points, if you will. So here's, let me actually download the F06 file. Even myself, I prefer to look at the file. I prefer to look at the raw file here. So if we scroll down, we have even more monitor points that are being output. And again, the same data. If you need to quickly output this data, my recommendation, avoid reading the F06 file as much as possible. Use Python. Use the HDF5 Explorer. I know some of you might have access to an OP2 reader. Read the OP2 file. Read the H5 file. Use the F06 file as like a last resort. So here we open the H5 file in the HDF5 Explorer. We'll pick the MONPNT2 dataset. Here you'll see we have even more rows. We're tracking data for more elements, for more monitor points. Click on download CSV file. So this other new CSV file, acquired dataset 1. So that would be this dataset. Let's see if I can make this work. Let's just go ahead and delete this. If you wanted to, you could create a bar chart. You can create, or here is just one example. If you wanted to, you can take these values and now do some additional calculations if you wanted to. Okay, so that is how you use a CSV file to create hundreds or thousands of these monitor points. Okay, now let me show you one last thing. Let me see. What's there next to do? Okay, let me do this. Let me show you a much faster way of possibly doing this. If you remember, we wanted to track the force along the x-axis for those elements. So here in this other window, these are the element IDs. So let me actually show you these elements real quick. So we wanted to get the element force along the x-axis for these elements. Okay, let's suppose we're starting from scratch. This process is without the monitor points. Step 1, run your analysis. Step 2, open the file in the HDF5 Explorer, which would be this file. Here on the left side, select this dataset element force, copy those element IDs here, and click acquire dataset. Oh, I think let me use this other data set. Okay, I'll have to explain what's going on here in a moment. Let's go ahead and look at this. I think there might be something. Oh, I know what's wrong. The force data set is using set, and that set 101 is only using one element. So if you look here on the right side, force is pointing to set 101. Set 101 is only pointing to element 1341. So here what was happening is there's no data for the other elements. I only have data for element 1341. So that's why there was an error here. So what I need to do here, I need to set this to all and then rerun this. So let me restart this whole quick demo here. So let's assume we never defined a monitor point 2. The only thing we know is that we want forces for these element IDs. This is what you would do. You would open the H5 file in the HDF5 Explorer. Let me see, where am I at here? Right, so you open the H5 file in the HDF5 Explorer. You would use that list of element IDs to do a query. You say, for these element IDs, get the element forces. So we'll select this element force quad 4 data set. We'll type in the element IDs. We'll click acquire, and then we'll download the CSV file. So this column, MX, this has the element forces for, how do I say, the x-axis of these elements. So here you saw that I didn't have to spend 1 or 2 hours defining all these monitor points. No, I just went ahead, I queried data for just these element IDs, and now I have the same data in this other data set. So here's that same data. Let's see if this will work. Let's go ahead and try and create a bar chart. And I suspect this will look very similar to what we had before, right? So you see there's some resemblance there. So this bar chart was created with monitor point 2 entries, and you can see that took a while. This alternative method was, you know what, just I know we have force data available, just get data for these element IDs. That took a few seconds, and now we have a bar chart. And we have additional quantities. We have quantities for My, force along the y-axis. We have shear force. And one last thing, I haven't tried this, but let's see if it works. Oh, it doesn't work. Here, forget what I was just going to say. Okay, right. So this last method, in my opinion, was a little faster. Here, I'll give you another example. Suppose we want data for 2 of these elements as an example. Let's go ahead and see what element IDs these are. We want this element ID and this element ID. So 1516 and 1517. Here, one approach is you define MONPNT2 entries. You can see that kind of takes a while. You have to dig in the DMAP users guide. You have to find the correct name. That takes time. The alternative is use the HDF5 Explorer. We'll select the element force for the beam elements. We'll type in those element IDs. We'll click on acquire dataset, and here we go. The same data is now available here. We get the bending moments, the shear forces, and so on and so on. I could click on download CSV, and all of that is now available in a CSV file. Okay, let me look and see if there's anything else to go over today. Nope, I think that's pretty much it. So here, let's go ahead and just look at, or let's recap. The whole goal in this video was to extract the force and the stress along the x-axis of the element coordinate system for a C quad 4 element. You can see the process was in a way a little easy, but took a long time. Was trying to find the correct abbreviation for the quantity we wanted to use. You can see it's kind of buried in all these rows in the DMAP users guide. We went over how to create a few of these. We went over how to interpret the results. We went over how to output the results to CSV file. And then we went over a process to create hundreds or thousands of these MONPNT2 entries. And then we went over an easier alternative. I don't know what works best for everyone, but it's good to know that there are different ways of going about this. So I thought this was a good video where I could show you different ways of getting that data. Okay, we're pretty much at the end of the video. I think one thing I haven't been leaving you off with is my contact information. So just in case you have a question, feel free to reach out to me at this email address, and I will get to you as quick as possible. So there you have it. That's how you create MONPNT2 entries.